This video is going to be taking you through distributions, so normal distributions and skewed distributions, which includes positively skewed distributions and negatively skewed distributions. You may have come across these before without knowing it. Anytime we talk about something called a bell curve, we're talking about a normal distribution. So normal distributions are symmetrical, bell-shaped frequency distribution curves. Most of the data in a normal distribution tends to cluster around the mean, which we'll look at in just a moment. And the further a data point is from the mean, the less likely it is to occur. And this can be really useful in psychology because it can tell us in a statistical way what is normal and what is abnormal and may therefore need intervention. So let's have a look at the features of a normal distribution here. If you measure certain variables, particularly psychological traits, the frequency of these measurements often forms what's called a bell curve, or in statistics, a normal distribution. These traits could include something like height or shoe size, in terms of psychology, short-term memory capacity, self-reported levels of happiness, and typically IQ, which you can see here on the screen. So if we just have a look at our axes for a moment, we can see on our x-axis here, we've got the IQ score, ranging here from below 55 all the way up to 145. When we look at the y-axis, we can see that this denotes frequency. So in this case, the percentage of population. So frequency is how often a score occurs. So when we look at this graph, we can see a few things. We can see that within the normal distribution, most people are located within the middle. So in this case, average scores are typical scores. So if we have a look in this dark blue or navy area here, we can see that 68% of people's scores fall within one standard deviation above and below the mean of IQ, of course, being 100. So 68% of people will have a score between 85 and 115. We can see that 95% of people have an IQ score of between 2 standard deviations below and above the mean. So 95% of people will have a score between 70 and 130. And we know that extremely high and extremely low scores are very rare. So we know that greater than 3 standard deviations above or below the mean lies a very, very small percentage of people. So 99.7 people, more or less, roughly, will fall within 3 standard deviations of the mean of 100. And then beyond this, we have a few outliers that will get very extremely high scores in terms of the genius category and very, very low scores in terms of the intellectual disability category. So normal distributions are really helpful because they can tell us in a mathematical way, in a more objective way, what is normal and what is abnormal. So let's have a look at the characteristics of a normal distribution. So first of all, normal distributions are symmetrical, which means that 50% of the data lies above the mean and 50% of the data lies below the mean. Normal distributions are unimodal, which means that we've only got one peak. We can get bimodal distributions. So an example of a bimodal distribution could be peak restaurant hours. This would be lunch and this would be dinner. We could also have, for example, height, where here we would see the median, or the mode female height, and here we would see the mode and most frequently occurring male height. But in this case here, we're looking at a unimodal, so one peak in our distribution. Normal distributions are also asymptotic. So in this case, it means that the scores approach but never touch the x-axis. So they therefore never reach 0. And this is because more extreme scores are always theoretically possible. So we could always have very, very, very high IQs of, say, 200 or more. Although theoretically possible, it's very, very rare. But for that reason, the distribution never touches the x-axis, the horizontal axis, and therefore never reaches 0. And the other really nifty feature of a normal distribution is that our measures of central tendency, our mean, our median, and our mode, are always equal or very, very close to equal. So although they might not necessarily be identical, they're always going to be very, very close. So how do you know if a data set is normally distributed? The first thing we need to do is examine this visually. Does the data appear to be symmetrical? And we can do this by looking at both a table or by looking at a histogram. If it's too difficult to determine it visually, then we need to calculate our measures of central tendency. So we need to determine what our mean, our median, and our mode are. If they're similar or identical, then we know we've got a normal distribution. If not, as we'll see in a moment, we've got a skewed distribution of some kind. If we're then still not sure, we can plot the frequency distribution in a histogram, and we'll know that we're looking for a symmetrical bell-shaped curve. So let's have a look what this looks like in a table. So here, looking at this table, I can see immediately what type of distribution this is. The first thing we're looking out for is symmetry. And I can see here that we do have almost perfect symmetry with 50 here. So if we're plotting this just roughly, and say this is scores on a test, and our percentage ranging from 0 to 100, I can see that the most frequently occurring score was 50%. So I know that my peak, remember frequency is how often a score occurs, so our mode here, our most frequently occurring score, is going to be 20. If I then look at either side of this mode, we've got 15 people getting a score of 40% and 15 getting 60%. We've got 12 people getting a percentage of 30% and 12 people 70%. And I can see that this is a perfectly symmetrical distribution of scores just by looking at this data in the table. So I know that with my mode up here of 50%, our most frequently occurring score, that my distribution is going to look something like this. I know that's not perfect, but that's just my drawing. But you can see here that this is a symmetrical, unimodal, asymptotic distribution of scores. Now, distributions are not always symmetrical. It doesn't always work out like that, unfortunately. If the distribution of scores is not symmetrical, if it appears to lean to one side or another, then we've got a skewed distribution. And our skewed distributions can either be positively skewed or negatively skewed. So let's have a look at what that means. Let's have a look here first of all at our negative skew on the left-hand side of your screen. We can see here immediately that our negative skew contains more high scores than low scores. So most of the distribution is concentrated here on the right-hand side of the graph, denoted by high scores. So again, let's pretend that this is percentage on a test. This is 0% and 100% here. We can see that most of the scores are high. The distribution is concentrated on the right-hand side of this graph with a long tail here on the left. So I want you to imagine here a really easy test where most students, the majority of students, have done really well and have achieved really high scores, with a few achieving very, very low scores on the test. Let's then just change for a moment to look at a positively skewed distribution. Again, let's take percentage on a test as our distribution of scores. We can see with a positive skew, it contains more low scores than high scores. We can see that most people have done pretty poorly on this test. Most people have achieved a really low score, with a handful, just a small number of students getting really, really high scores, closer to the 100%. So we can see here that our distribution is concentrated on the left of the graph, with a long tail down here on the right. So a very difficult test where most students have done pretty badly and achieved low scores, with a few really high achieving scores, hence the tail here on the right-hand side. What's particularly interesting about skewed distributions is the effect that these distributions have on our measures of central tendency, the position of our mean, our median, and our mode. Our mode is always going to be, unsurprisingly, at the peak of our distribution. If we remember what our x-axis is, our y-axis is always the frequency, or how many students achieved that score. So if this is frequency, then most students here achieved a score of, let's say, 75%. If we look at our positively skewed distribution for a moment, again, we can see that our mode is the peak of our graph there. And here, perhaps, let's say this is 25%. So the mode, unsurprisingly, will always remain at the highest peak, the highest point of that peak. The median, being the middle score in our data set, remains in the middle. Here is our mode. here is our median, is going to be in the middle. What's really interesting is going to be the placement of our mean. So here we go. So in a negative skew, our mode is always going to be at the highest point of the peak, with our median slightly to the left, and then our mean dragged even further down to the left. This is because we've got a handful of very, very low scores dragging down the mean. So if again we think back to a class, we've got most of the students achieving some high scores here, with the most frequently occurring score being about 75% on that test. Unfortunately though, we've got a handful of students who haven't revised who are dragging down the overall class mean, making the mean a lower score than the mode. And why is this happening? Well, the mean, unlike the mode and the median, is the only measure that takes all of the scores in a data set into account. So the mean, unlike the mode and median, is going to be affected by extremely high or extremely low outlying scores. So in a negative skew, our mode is always going to be greater than our mean. In this case, our mode is about 75%, and this is greater than our mean of, for example, just roughly 50%. The opposite is true for a positive skew. So when we look at a positively skewed data set, we can see again our mode is up here at the highest point of the peak, followed by our median, which is the middle number in all of our data set. And we can see that our mean here is going to be higher than our mode, because we've got, although the whole class as a whole did pretty poorly on this test, with most people not getting above 50%, we've got a few excellent students that have worked their socks off and got really, really high scores that are pulling up our mean. And so they're creating a higher class average than perhaps it would look like when we were considering the mean and the median. So in a positive skew, our mean is always higher, say 75%, than our mode at 25%. So a teacher looking at these distributions needs to make a few changes. So if we look at our negatively skewed distribution, we've got most students doing really, really well and achieving high scores, meaning it's probably going to be quite difficult to differentiate between the top achievers. So this teacher, knowing that most students doing really well on this test, probably should make this test a little bit more difficult so that we can get more of a normal distribution of those scores. On the other hand, when we look at the positively skewed distribution, this would be raising alarm bells for a lot of teachers. This test is far too difficult, or the students just haven't learned or revised the material. If Mr. Jones looks at this spread of scores, he's going to be asking some questions. It's not going to look too good. So this teacher might choose to make this test a little bit easier, and so these students who are achieving low scores have a chance to do a little bit better, and therefore we might see more of a normal distribution. It's really important that you're able to, on a graph, sketch a distribution, whether it's normal or skewed, and also identify where the mode, median, and mean would sit. That's usually rough. You don't usually have to calculate your measures of central tendency before you plot them on a graph, but you should know whether the mode or the mean is higher in a negative or a positively skewed distribution. It's important also that you can look at a data set and be able to determine whether it's going to be skewed or normal. So let's have a look at this distribution of scores in the table here. Again, at first glance, it should be immediately obvious what type of distribution we're looking at here. If we look at our mode, this is our easiest one to plot on a distribution. We can see that the most frequently occurring score is 70%. So again, if we've got a test here with our range of scores from 0% to 100%, our mode is going to be somewhere up here at the 70% mark. We can see that we've got very few people getting low scores, and we've got most people achieving 60 to 100%. So this tells me that I've got a tail here with a low frequency, or only a few students achieving very, very low scores. I can see that the most frequently occurring score is 70%, and then most scores are clustering at that right-hand side of the graph. So most of them are distributed on the right-hand side, mostly high-achieving scores. So we can see here that the majority of scores are high scores with a tail here, so very few low scores. So I can see here that this is a negative distribution or a negatively skewed distribution. If we have a look at our next data set here, we can see something else happening entirely. So immediately I can see that there are very, very few high scores. I can see that my mode, my most frequently, that's not it. My most frequently occurring score is 15. So if we plot this again on our graph, our scores ranging there on our x-axis from 0 to 100%, I can see that the most frequently occurring score is 15%. Sorry, is 40%. There we go. And we can see that most of our scores are low scores, with very, very few students achieving above 70%. So we can see here most scores are low. Most students have done quite poorly on this test, with a few outliers here. So I can see that this is a positively skewed distribution. So, hopefully by the end of this video, you're able to explain the characteristics of a normal distribution. The idea that it's symmetrical, it's unimodal, it's asymptotic, and the mean, median, and the mode are all equal. You should be able to identify a normal distribution by looking at a table of scores to determine whether it's symmetrical and whether the scores are similar for the mean, median, and the mode. You should be able to identify a normal distribution also from a histogram. So looking at the distribution of scores on a graph, can you determine whether it is normally distributed or not? You should be able to also identify a skewed distribution from a table, so identify whether it is positively skewed or negatively skewed, and likewise for a histogram. And you should be able to understand where the mean, the median, and the mode fall on a normal and a skewed distribution. Finally, you should be able to describe the qualities of a test or a measure that produces a normal or a skewed distribution. So by that I mean, would you be able to provide recommendations to the psychologist or the teacher about what changes they may need to make to their test to create a more normal distribution? I.e., should the test be made more difficult, or should the test be made a little bit easier to produce a more normally skewed distribution?